Today we're going to talk about looping structures in .NET, but we're going to approach it from a more practical application. We're going to see how you can use a looping structure to iterate, that is to cycle through an array. And an array inside of .NET is something that we would call a data structure. Now, up until this point, we've been working with what you could say are atomic data types. In that, think of it from the perspective of like an atom, right? An atom is the smallest thing you can split an object into. And it's the same thing with what we would say are atomic data types, in that you can't split it up anymore without actually losing the data. So if you think about it, if we have something like an integer or a double or a Boolean or even a string, you could separate those out. If we had a double and the double was 26.5, you could split it up into the 26, right, which would be like an integer, and then the 0.5, which would be the decimal point and over. But if you do that, it's not the same data anymore. It's 26 and it's 0.05. Yeah, you could add it back together, but it's not the same data anymore. Same thing with the string. If you took a string that represented someone's name, say Jeff, for example, you could split that string up into individual characters, J, E, F, F, but once you do, it no longer represents a name anymore. It's just a series of characters. You could mix them up, or you could put them back together, but splitting it up is actually just sort of removing the data from it. Now, that brings us to arrays. We would say an array is a data structure in that it's made up of these atomic data types. So I could have something that would be an array of integers. I could have an array of strings. I could have an array of doubles. And what an array is it is a list. It is a sequence of these data types. So the best way, I think, to look at it would be to probably visualize it. And typically we envision an array sort of as a series of boxes. So for example, if these were, you see the cubby holes where you can put your shoes, that you see that in schools or daycares or, wherever, people's houses. And think of it as each of these as little cubby holes or boxes. And in each of these boxes, we can put one piece of data. So for example, if this was an array of strings, we could work with strings, and each of these boxes would contain one string. So I have some down here. I'm going to copy and move these up. Alright, and let's say this was an array of strings and we were tracking individual people's names. So Susie here would fit in the first spot, Tom in the second, Jeff in the third, Betty in the fourth, and Paul in the last. Now, the way arrays are handled in .NET is that the entire array has to be of the same type. We would say that array would be homogeneous. They all have to be the same type. If we wanted an array of integers, each of these pieces of data would have to be an integer. And this has a lot to do with how .NET addresses these pieces of data in memory. But the one that we're looking at right now would be an array of strings. Now, this is how we refer to the pieces of data themselves. Susie is in the first element, right? We'd say she's that element, and she's the first one in the array. Tom is the second. Jeff is the third. Betty is the fourth. And Paul is the fifth. However, we are working with computers. And computers like to start counting at 0. And so although as human beings we see these as 1, 2, 3, 4, and 5, we would actually say, I'll bring these up here, we would actually say that Susie is at the 0 index. Now, if you're talking about it to a person, saying Susie's in the first spot of the array is perfectly acceptable. But when we want to access Susie, we would say she's at the 0, and we'd say the index. And the index is tracking your position in all of this. So Susie's at 0, Tom is at 1, Jeff is at 2, Betty is at 3, and Paul is at 4. And this is how we count that. And when we access this through code, if we want to get the first spot, we would say at 0. So there's a couple different ideas spinning around here, okay? So although Susie's at the first spot, we'd say at 0. The whole thing, we selected the whole thing here, we would say this array has 5 elements to it. Each of these spots, each of these cubby holes, each of the boxes is an element. And it has 5 elements, or we would say the length of the array is 5. So although it counts up 0, 1, 2, 3, and 4, the length of the array itself is 5. And so we use these terms because, you know, although it's information for us as humans, we have to have some way of kind of bridging the gap between what we do and what the computer does. Okay? So in a very simplistic term, an array is really just a series of boxes, and those boxes, each of that box will hold a piece of data. But what does this look like in code? Well, let's fire up Visual Studio here. I have a project, I'm going to call it Loop with Arrays. Let's start that up. I'm going to drag a button on the form to get to the code behind. Double click, and we're going to see what it looks like to declare an array. Now an array has to be a particular type. It has to be an array of strings, an array of integers, or array of doubles, or any other of these basic data types. So that's how we start out, by declaring it. Now I'm going to declare an array of strings. So I'm going to say string, and then let's say that we were tracking students. Now, the naming convention for an array doesn't follow the same rules as you would have for a single string or just a simple variable, because then we would have done str. But because it's an array of students, and because it's an array, it's all right for me to just call it what it is. We don't have to do a prefix of it, because generally your application isn't going to have a lot of arrays. They're going to be used as containers to hold the data that your application is using. So you're gonna remember what they are, but specifically you want to name them something so it's very obvious what it is that you're tracking. Typically, because it's an array and there's multiple pieces of data inside, it's going to be plural like this. I'm tracking an array of students, so that's what I'm calling it. Now, left alone like this would just create a basic simple variable. But to make it an array, after our string, and remember, we use our visualization of boxes, right? So after our string, I'm going to make a box. And those are what we would call brackets. And so those are above your enter key. It's the same key that we use for our curly braces, but we don't hold the shift key down. So we have our brackets. And this would make an array. Now, to create an array with data in it, we say equals. This is an initialization statement, right? It's a declaration statement and an assignment statement together. So that's what makes it initialization. And we put angle bracket here and an angle bracket here, and then a semicolon. And this would create an empty array for us. But we don't want to create an empty array. We want to create an array that's got these names in it here. So Susie, Tom, Jeff, Betty, and Paul. So this is what we do. It's just like if we had a single variable. So because it's an array of strings, we would have to use our quotes. And I'm going to say Susie. This would be an array with one element in it. Rarely we would do this because if we only had one, we would just create a simple variable. So we want more than that. But how do we add another one at the end? Well, we separate our values out with a comma. So we say comma, and then we can go on and we can say Tom, comma, Jeff, comma, oops, don't forget your quotes because these are strings, Betty, and then lastly, Paul. And that's what our array would look like. Now, depending on what you have in here, that might, you notice it caused a little scroll off to the side already. It is possible that we could, if we wanted to, split out our data like this. After the comma, you would hit enter. And we can put each of these on their own line. This is really personal preference of how you like your data to look. You can have that brace in there just so that it's almost just like how you would use the syntax for a function or an if statement. And then each line kind of shows you that, yeah, that's the data for that array. That's what the array is made out of. These are all single unique elements in the array. And so that is what an array declaration would look like with data in it. We would say that we've initialized that array with that information. That is the same thing as what we had here in our picture. This is our design, right? And then this is actually what it would be implemented as inside of C#. And that's great. So we have an array here. Now, typically, you probably wouldn't hard code this data in. This data might be coming from a web service. It might be coming from an XML file. It might be coming from a database. In this case, though, we've hard coded these values in. And the actual use of the data is going to be the same no matter where it came from. But how would we get this data out? Well, we can use our friend, the message box, .show, and we'd want one of these pieces of data. Now, you could not just say students, because although this is a data structure, although it is an array of strings, the array itself is not a string. It's an array. That is a data type in and of itself. We want to be able to grab this out of these boxes that we've drawn here. Oops. We want to be able to grab these out of the boxes. In fact, what we're interested in is we want to grab out Susie. Now, this is where this counting, this indexing comes into play. We wanted Susie. She's in the first spot. She's at 0, and so this is how we access it. After students, that's our array name, we say, okay, well, that's in a box. The box is coming back out, and we want the box at position 0. We could say the first position or at index 0. So inside this box, you pass in the number that corresponds to the position of where they are in the array. Now, this is the array, but once you put the box on the end and you're grabbing it out, this entire expression right here, students, bracket 0, close bracket, evaluates out to a string because it's an array of strings, and each element taken by itself is going to evaluate to a string, and that's why we can use it inside of a message box show. So I'm going to run the program. I'm going to click my button, and if everything's gone right, it should come up with Susie. Let's change it now. Maybe I want Tom out of here. So Tom would go 0, 1. Tom is at the 1 index. Going to hit start. And there we go. And we're pulling Tom out. Now, we've been hard coding this value in, but if we wanted to, we could put this inside of our form and accept input out from our user that would tell them which element of the array that we want. But we have a better way to do this. We have a control that will display a list of data that we can initialize with our looping structure and then allow the user to select it from that. So on my form, I'm going to pull out of my toolbox a list box. Move my button down. And we're going to call this list box LBX students. I'm going to call this button BTN load. That's what's going to populate our list box. And then I'm going to change the font on both of these to be bigger. Okay, so what I want to do is on this button click, I want to take all the contents of my array and I want to fill up the list box with that. Now what we could do, because we've already seen what it takes to pull out a single student, and I comment this out, we don't need that anymore, is I could add each of these elements in my array individually. I could say lbx students dot items dot add, and I can say students 1, and this is going to add Tom to my list box. And I'm going to run it, and I'll click load, and there we have it. And I could go on, so on and so forth. We already missed Susie, so maybe we'll do Susie, and we'll say 0, and then we'll add Jeff. But we can see that we're kind of setting ourselves up for trouble later. Because what if we wanted to add someone on here? What if we wanted to add a John on? Even if I had every single element in my array, if I was going 1 through 5, I would have had to go back into my code here and not only add John here, but then also add an additional line so that John gets added into the list box. And we can see that it's not very dynamic. And a situation like this is perfect for one of our looping structures, specifically for our while loop, because we have a bunch of things, almost a bunch of instructions that the while loop can loop through for us. This is work that computers love. It's repetitious. And so how do we do this? Well, just as in any loop, we need our counter. We need a stop condition to tell us when we're done. And then we lastly need an accumulator. The accumulator is always going to be the thing that does the work. In this case, it's not immediately apparent, but our list box is actually going to be what's accumulating our data. So before we do this, we need to declare a counter. I'm going to go I. I is going to be I for index. I for index is going to tell us what position we are inside of our array. Next up, we need our stop condition. So we say while I is less than, and we can do this. We can say 1, 2, 3, 4, 5, 6. We have 6 elements in our array, and so our loop is going to run 6 times. Remember, our while loop goes while true. Do my brackets of the code that I want to repeat 6 times, and now in here we say lbx students dot items dot add, and now this is where we pull that out of our array. So I say my students box. Now remember, before we did 0, and then as we cycled through it, we went to 1 and 2 and 3, and we would go all the way up to 5. Remember, we don't go to 6. There are 6 elements in the array, but the array starts counting at 0. So we'd actually go through 0, 1, 2, 3, 4, and 5. Now, coincidentally, that's exactly what our loop is going to do, right? So every time in my loop, if I'm incrementing I by 1, can't I do this? Can't I use I here? The first time it's going to start out at 0. That's going to pull in Susie. Then it goes I++. So the second time around, I is 1. Then that means it's going to pull Tom out of here. Then we have Jeff. It's going to go to 2. I++ is going to go to 3. That's going to pull in Betty. 4 and then 5. When it gets to 6, the while loop goes while 6 is less than 6. Well, 6 is not less than 6. So this would evaluate to false, and then the loop is done. So let's run this. And we're going to click load, and sure enough, it pulled in all of our data because it looped through the array for us. It did the work for us. What would happen if we went past the outside of the array? Well, let's try that. Maybe we didn't get our math right. Maybe we decided that John dropped our class or something like that, and we went with this. Now we only have 5 elements, but if you look, the loop is going to run 6 times. So I'm going to go here, I'm going to click load, and I'm going to get an error. The error I'm going to get is index was outside the bounds of the array. This means that you kept walking off the pier. All right, you couldn't tell where the pier was, and you ended up in the lake. You ran out of boards to walk on. The way that this works is that this actually lives somewhere inside of memory. And when you declare it with this data, it sets up a spot for each of these. Well, when you go too far, you actually run out of array. There's no more allocated space in memory, so what your application is actually doing is an illegal memory access. It's trying to access memory. It doesn't have permission to, and you're going to get this error. Best case scenario, if it let us do this, you might get some data that looks proper. It might come out as letters, but it could be jumbled because it's binary data from another program. Worst case scenario is you're actually accessing another program's memory, which could cause a different application to crash. And that's essentially how certain exploits work inside of memory. .NET does its best to isolate the applications from having permission to do that. Regardless, as a developer, that's just something that we simply cannot do. To avoid this, we don't want to hard code in this value. We want to have our array actually help us out. And it gets tricky because if we had 20 or 30 elements in here, you can't be going through here and counting each one. It turns out that the array actually knows how long it is and how far our loop should go. So we say I is less than students dot length. In this case, length is 1, 2, 3, 4, 5. And I can run it, and it's going to work perfectly. I can add John back in, and it's going to run, and it's even going to pull John in. I can remove John and Paul if I want to. Get rid of that trailing comma. And although it's at length, and although I didn't touch this line of code, I can still load it, and it's going to pull that in, and nothing's going to get crashed. Now, we've worked with selecting these things, but let's do that again. Let's say that I have some other data. Maybe I'm tracking in a separate array how many credits each of these students has. And what I want to do is when I run my application, I want to be able to pick one of these students, and I want their other information to display over here for us. And so what we want to kind of latch onto is this event where I'm actually going through and selecting these things. And so I double click on here, and that will create a selected index change event. But we don't have any other information. And we're also running into a different problem. This array here, now I want this to be accessed on two different events. I want this to be accessed when I click the button to load it, and then I also want it to be accessed when I click each of these items. So we have to move this out of here, and we have to make this array a class variable. So after my public partial class, I'm going to take that array and I'm going to post it out as a class variable, because this has to be accessed on two different functions in my code. And as long as we're here, let's create that other array that's going to track how many credits each of these students have. Now we've created an array of strings. Now we're going to create an array of integers. So we do the type. We say box because that's going to say to the compiler that we want to create an array of integers. And I'm going to call this one credits. And now do my busy work, and I want to put credits for each of these. So I have 1, 2, 3, 4, 5, 6, and we'll create credits for each of these. So let's say that we have Susie's got 34 credits, and Tom has 67, and Jeff has 22, and Betty has 89, Paul has 0, and John has 21. And so this would be how we would track corresponding data. And think of this like the rows inside of a spreadsheet. If I pull up Microsoft Office, if we track this data inside of a spreadsheet, we would say something like this. We would have a column that was student, and then we'd have a column that was credit. Now, how do we have over here? We have Susie, and we said Susie's got 34 credits. We have Tom. Tom's got 67. Jeff has 22, and so on and so forth. And if we were looking at this inside of a spreadsheet, it'd be no problem. We'd say, oh yeah, Susie, 34, Tom, 67, Jeff, 22. That's the same thing that we're doing here. But the way that we're structuring our data out in here, we're tracking so that each of these columns is its own array. But the organization of it still holds. So Susie is at index 0. Her credits are at index 0 on the other array. Tom is at index 1. His credits are at index 1 on the other array. So what we can do now is that when they are picked inside of this form, we can use their position to pull out the data from both of the arrays. And so I'm going to add on 2 labels. Actually, more than that. I'll add 4 labels on here. And we're going to display that data out. I'm going to call the first one LBL student, and the second one LBL credits. Okay, so when someone picks one of these items, it's going to cause the index, we'd say the selected index, to change. That selected index is also zero-based. That's why we start doing this zero-based, because that's what all the parts of .NET use as well. So Susie's going to have a selected index of 0, Tom's going to have a selected index of 1, Jeff of 2, and so on. And so we can use that to pull the data out of the array. So inside of our selected index event, I'm actually going to pull that out. I'm going to say int I equals lbx students dot selected index. And now I can say lbl student dot text equals students I. If they picked the 0 one, it's going to pull out Susie. If they picked the second one, it's going to pull out Tom. And so we can use that back down here. So I'm pulling the student out now, and now I can pull out credits. And instead of pulling students I, I'm going to say credits I. Now, I'm going to hit enter, and that's going to give me an error here. It's going to be an error. It's going to say cannot convert type int to string. Remember, credits by itself is an array, but credits I is an integer. So we can pull off of the integer just like we would a normal integer variable, and I can say dot toString, because this evaluates out to an integer. So anything I can do on a normal integer, I can do on the array as long as I'm specifying the index. So I'll hit load, and then Susie has 34 credits, Tom has 67, Jeff 22, Betty 89, Paul 0, and John 21. So this would be how I would use an array to populate a list box. But you can't just do it by yourself. You need to use that while loop. And yes, you could hard code those values in, but you'd be setting yourself up for a lot of work. Especially if these two arrays were coming from a database, we might not know how many elements are in there until we would say the program is running or at runtime. And that's why a while loop is great. Is I can run my while loop, I can get the array length from students.length, that tells me how many times my array has to run, and then I loop through there each iteration. I pull that value out of students, and then I increment it by 1, and I loop it until everything has been pulled out of the array. So this really shows you how while loops are used to really do the work in an application. They're great at counting up, but they're even better at looping through sequences of data that are inside of an array. So when you have an array, it's almost always going to have some sort of matching looping structure inside of the code.